Hi, it's me Kubir Luha, and in this video I'm going to hands-on circuit analysis Wheatstone bridge with low pass filter. Okay, so basically in this experiment there are three parts, so we will do one by one. So these are the components required for this experiment. Is that four resistor R1, R2, R3, R4 for Wheatstone bridge is that is 100 kilo ohm, and two 1 kilo ohm resistor, two 10 kilo ohm resistor, and one capacitor which is in nanofarad. Okay, and one multimeter and one ADLM kit. So first part is about Wheatstone bridge measurement, second part is about Wheatstone bridge not in balance condition, and third part is about low pass filtering. Okay, so let's do it. You can see this is Wheatstone bridge, and here E is extrusion voltage, and R1, R2 and R3 is equal for part 1. Basically this is 100 kilo ohm, and we have to calculate node A, node B and output voltage. So first, calculating for node A, we have to record that Wheatstone bridge, and we assume that the extrusion voltage is that is 2.5 volt. Okay, so for calculating node A, R2 upon R1 plus R2 into that extrusion voltage, which is 1.25, and also it is similar for node B, it will be 1.25, and when we'll calculate output voltage, then this is VA minus VB, which is 0. Okay, so let's do it in practically. Okay, this is one resistor of 100 kilo ohm, so I have to confirm about it. So you can see this is approximately 100, or it is 100, something is error in this case. Okay, I have said all this component as per the diagram. You can see these are four resistor of 100 kilo ohm, and I have to measure now the voltages of extrusion voltages. Okay, so first thing, I have to apply this extrusion voltage from ADLM kit. Okay, so here's I connect this one in 2.5 volt. Okay, so let's connect this one in, and this one is grounded. Okay, let's do this one very fast. Okay, now I have a multimeter. I have to set this one in 20 volt and calculate. You can see it is 2.46 approximately, which is approximately 2.5 basically, right? I have to measure node A and node B. So for measure node A and node B, it should be approximately 1 point something. Okay, it's 1.17, and node B is it is also okay, it is also 1.17. Okay, now all data are noted, and we have to calculate node A, node B and output voltage. We took now extrusion voltage is, which is 2.5 plus 1 sin omega t. Okay, and once again R1, R2, R3 and R4 are same 100 kilo ohm. Now for calculating node A, node A will be 1.25 plus 0.5 sin omega t, and node B will be 1.25 plus 0.5 sin omega t, and after the output voltage will be, which is equal to VA minus VB, will be equal to 0 voltage. In sixth part, we have to use pixel plus for this voltage output. So what we have to do for this case, I will take 2.5 volt extrusion volt 2.5 plus 1 sin omega t from channel A, and I have to check this voltage from channel B. You can see that peak to peak voltage is 1.7 volt, and it is slightly increase or slightly decrease time to time. Okay, 7 point of part 1 is that Wheatstone bridge to be balanced. Okay, so for balance Wheatstone bridge, that must be R2 upon R1 is equal to R3 upon, R1 upon R3. Okay, and these are the value, the initial value of that we have to take this value for Wheatstone bridge balance, that is R1 is equal to 1 kilo ohm, R2 is equal to 10 kilo ohm, R3, and you can see a will be 2.2727 voltage, and similarly with node B, it will be also 2.2727 voltage. Okay, now for output voltage, and that will be 0. Okay, for 7 point, I have just replaced 100 kilo ohm with 10 kilo ohm. So this one is 10 kilo ohm resistor, and this one is 10 kilo ohm resistor, and this one is 1 kilo ohm resistor. Okay, so for now we have to measure the nodes. Okay, so first find the output voltage. Okay, you can see this is the output voltage, which is 2.46. Now I have to find the node B. Okay, so node B is all 2.23, and node A, which is 2.22. so same thing. Okay, now moving forward to part 2. Part 2 is about not in balance condition. Okay, so for not in balance condition, what we have to do, just we have to add 1 kilo ohm resistor in R1 and R4. Okay, so now that will become 101 kilo ohm, and R4 become 101 kilo ohm. And now let's calculate node A. So for calculating node A, it will be very simple. That is 1.2438 volt, and node B will be 1.2562 volt. Okay, in this case node B is slightly slightly more than node A, so output voltage will be in negative. I have said all this component for part 2, and this for unbalanced Wheatstone bridge. So this one and this one is 1 kilo ohm of resistor. And this all this are four all this 4 resistor are 100 kilo ohm resistor. Okay, now I have to find node A and node B and calculate output voltage 1.7 something. Okay, So okay, now node B is that is 1.9 some 1 point output voltage that minus point something. So okay, the value is slightly different because something is problem in the circuit, but it's okay. Now discuss about part 3. So part 3 is about low pass filtering. Okay, so we have to find the corner frequency for this, and register that is R1 and R4 is 101 kilo ohm, and R2 and R3 we took this one in 100 kilo ohm. Okay, our existence voltage, which is existence voltage, is that is 2.5 plus 1 sine omega t. Okay, now let's calculate this one, which is first for calculating corner frequency we have to calculate the equivalent resistance. Okay, so for equivalent resistance we have to calculate this one, R1 plus R2 minus R3 plus R4 whole divided by R1 plus R2 plus R3 plus R4. Okay, now R equivalent is 100 plus 5 kilo ohm in this case, and the formula of that corner frequency is that is 1 by 2 pi R equivalent and into capacitor. Okay, and which is approximately 159 hertz. I have said all these components for part 3, and part 3 is all about low pass filter. So you can see I use this this capacitor which is in nanofarad, and this channel A is connected here, and this channel B is connected here, and this one is grounded, which is connected the one terminal of this capacitor. Okay, so now let's so in this pixel plus 3 I use this circuit in pixel plus, and now you can see in this case it is the volt, this RMS value is 0.3519, and so we have completed all this part 1, part 2, and part 3. Now this one is a calculation of frequency and output voltage. Okay, this was a 1 hertz of frequency, which is 1.79 of output voltage, and likewise it is slightly decreases, then sometimes constant, and slightly also once again decreases likewise. Okay, so this was our experiment of week 2 of electronics lab. Thank you.